infinity and back again. I'm to them. Young dog and I talking. You know once in the shine, don't vex when you get married. Me nah make trouble stress my brain. Cut checks, me I cut to the chase. Star never second hand, never second hand, man. Never stopping for a second, nothing up on the line. Look a jump and sound, I go try and make
hosting us this evening. It's a fantastic venue tonight. We've got a great night in store, and this platform is part of our Source Talks community. This is to connect great people like yourselves across the .NET ecosystem. But look, just a bit on Source Technology. We are a recruitment company placing technology staff in across a variety of industries. And then I myself actually work in .NET, again working across a variety of industries myself. But look, less about that and more about our great speakers tonight. So the agenda will be to have David speak. He'll be our first speaker, and then a small break to go have some more drinks, to go to the loo, or even just get some more crisps and some food, which is on its way. Followed by that will be another great speaker in Ian here, who's just sat at the front here. Each talk will last about 45 minutes to an hour with a Q&A afterwards as well. After, we are going to be heading over to the Star of Kings, which is just around the corner, if anyone does fancy a few drinks afterwards as well. But now, look, let's get on to the fun part. Less from me, and I'll just introduce David Whitney. Get a round of applause, please.
Hello, hello, hello. You now get to watch me work out whether I can present in Teams, which is a challenge for everybody all the time. Did it work? It worked. Amazing. Let's hope the rest of it works, otherwise we're kind of stuffed. So hi, I'm David. I work here, which is convenient. I didn't have to travel far to actually come and do this piece, which is very, very nice. And yeah, so I appreciate we didn't put any titles on the talk, so thank you for all showing up to the title list. We're going to talk about some programming stuff, because what I want to talk to you about today is ironically not programming stuff. It's kind of ethics and lots of scary things. So I got a really combative title here, open source exploitation. Now, the truth is, when I wrote this, I couldn't find a title for this talk that worked. It's horrible and it's difficult, because all of the titles that I had in my head sounded so relentlessly negative that I kind of honestly didn't want to use them. So I promised that this talk isn't about being relentlessly negative. It's a talk about the work that we have to do to be better as a software industry. And as someone that doesn't believe in hills or like walking, and I'm definitely not into hiking, I don't like dying on anything big. This, I think, is the hill that I have to die on, and not knock this expensive microphone off the table while I do it. So I want to talk today about how open source in most cases has been turned into exploitation by the largest organizations in the world, how it's used to extricate free labor from everybody in this room, and why that's fundamentally probably a bad thing, actually. I want to talk about how we can do better. I'm going to talk about what I think needs to change in software to make it better. And, I want to talk about how I can take something that I dearly, dearly love and help it survive. Because I think right now open source is in the most precarious place it's ever been in its entire history. And I kind of feel like nobody notices. Really, really weird. Oh, that's the title slide that I already did. I work here. It's fine. Don't worry. That's me. It's a much more flattering photo than me in real life. So I'm going to skip past it. Right. So before I start with the really gory details, I want to talk about loving things, and like really, really, really loving things. Most importantly, I want to explain how it's important to be critical of things that you really, really love because you want them to be better, right? Not because you want to harm them, not because you don't believe in them. I've been building open source software since the actual 90s, when the internet was a village and everything was tiny, when I was tiny. But it's important to understand that any journey of maturity, the techniques and opinions and approaches that get you from A to B, and not necessarily the things that you need to get you from B to C, right? As context changes, the things that you need to do change. And people really frequently struggle with this fact because, humans are kind of these beautiful and simplistic creatures that often think because something worked once, it's going to work again and again and again and again, regardless of the context around them. So as technologists in an industry, we're going to have to embrace change if we want to survive. So this is like a common sentiment you'll hear when people talk about open source. Well, open source won the fight. You know, you all use Visual Studio Code in 2018. That's the stat. That's like 7 years ago now. 40% of Azure VMs are Linux, like Microsoft's VMs. Open source won the hearts and minds of people by telling them that software could and should be free. But what does free really mean? Right? So while the GPL and its variants were probably not the first permissive and free software licenses, they were the licenses that rapidly gained the mind share of most of the people in the open source community with the rising popularization of Linux in the 90s. So Linux really is kind of the, it was the tip of the spear that pushed open source into the mainstream. And its GPL license, originally described by the Free Software Foundation as free as in speech, not as in beer. Hands for anyone that's heard that phrase before. I don't know whether it's disappeared into history. Interesting, right? It's like a confounding statement that a lot of people struggle to understand the semantic meaning behind because it's kind of punny, right? So what does the GPL really mean in simple terms, right? It means if you use source code that's available under its license, you need to make your changes public for other people to use. So this is because the Free Software Foundation promoted the concept of software freedoms, right? And hear the word free like liberation, right? Liberation from constraints. It's literally the right of software to be liberated so that its users could modify, inspect, and make their own changes to it. Now, you know what? It's kind of a noble goal, right? Cool idea. And it shows that the lineage of the license really was used to build a Unix clone that was supposed to be freely available because it was built by a student who couldn't afford to license Unix. Right? It was a goal centered around people sharing source code at local computing clubs. And it's important to stress that free never really meant free from cost. It was always free as in freedom. And in fact, much of the original literature focuses on this by describing software that is free from cost as gratis. So when they mean you don't pay for it, they say gratis. Now, I like this piece from like the Free Software Foundation on this really. Does free software mean using the GPL? Well, not at all. There are many other free software licenses. We have an incomplete list. Any license that provides the user a certain specific set of freedoms is a free software license. Why should I use the GNU GPL rather than other licenses? Well, using it will require that software released improved versions be free as well. This means you can avoid the risk of having to compete with proprietary modified versions of your own work. This is foreshadowing. However, in some special cases, it can be better to use more permissive licenses. Now, it wasn't that version of the free software that really won, to be honest. Like Linux was cool and all, but it was a hobby project when a lot of this stuff started kicking off. And permissive licenses were easier to use than the GPL. They were safer to adopt for organizations because they didn't come with any additional burdens. So despite Linux and the early limited forays into open source organizations like, say, Red Hat back in the late 90s, strong copyleft licenses of the GPL were not the reason open source became dominant in the market today. And they're certainly not the reason that like ultra mega corps like Microsoft and Amazon and Google champion open source software. The widespread adoption of open source was largely pretty directly powered by the MIT license and the Apache permissive licenses of the late 90s and the early 2000s. And the difference between the GPL and MIT and Apache is they do not force the wider community to reshare modifications to source code. Now, permissive licensing allows individuals or organizations to take your work, build on top of it, operate those modified copies for profit. Much like the GPL, though, the aim of open source was not to restrict commercial exploitation, but to ensure the freedom of software. But here's the thing, who benefits from permissive licensing of the work that you do? Well, it's a trick question, right? Because in any situation where there's a severe power imbalance, let's say between the 4 or 5 largest software organizations in the world and you, awkward, the organization is always the person that benefits. Now, without wanting to sound terrible, I assure you I deeply love open source and software freedom and the combinatorial value that adds to teaching and to our peers and to each other. I cannot say more loudly, multinational organizations don't give a single solitary fuck about you, and businesses do not care about you, right? But you know what they do really care about? They care about free shareholder value that they're able to commercially exploit, right? The wide proliferation of software in businesses is a direct result of licenses like the Apache license and the MIT license being leveraged into closed source proprietary for-profit work. So want to test this theory? Go into your office tomorrow and try add some GPL code to your code base. See what happens. See how your line manager responds. Permissive licenses explicitly and without recourse shift the balance of power towards large technical organizations and away from individual authors and creators, always. They have the might to leverage the code, they have the capacity to build upon it, and they have the incentive and organizational structures to profit from doing so. Open source software only took hold in enterprise because it allowed itself to be exploited. Oh, come on, exploited. That's a bit rich, isn't it? It's a bit strong, combative language. No, let's go with it. Exploitation, the act or fact of treating someone unfairly in order to benefit from their work. It's awkward. The action of making use of and benefiting from resources. The fact of making use of a situation to gain an unfair advantage for oneself. Open source software is written by some of the most talented and smart professionals on the world. Surely, they are smarter than to let themselves just be leveraged like this. Lol. So this is the truth, right? And we've all seen this meme, and if you haven't, it's the truth, right? It's widely reported. The vast majority of open source software and projects aren't funded, even important ones. There is no art without patronage. None. The only successful open source projects in the world are either backed by enormous companies that use them for strategic marketing or product positioning advantage. Hello, Visual Studio Code, you are the product. Or B, they rely on exploitation of free labor to the gain of the organizations operating the products or services. So everything that Amazon have ever done. I can see everyone like a lot of the pitchforks start to come out, but GitHubs have donations. Oh dear. What about Patreon? I donated once, right? The presence of a welfare state does not preclude the need for charity. And when I see people make these arguments, I see them undermine themselves, right? We've all watched our peers and our friends burn out. We've watched people trying to get by doing dual licensing of software that they make. We've watched them get verbally assaulted, shouted down on the internet when they introduced dual licensing to try and make a living, by their own peers for not being free enough, right? And the truth is, we've watched people go to the effort and doing all the legal legwork to set up organizations, to sell support contracts, and then those organizations end up with single-digit clients for that actually bothered to go and buy those things. We've seen packages with 20 million downloads languish and lead to security exploits when they've been handed over to third-party bad actors just because nobody is willing to pay for the work. It's a hellscape. It victimizes creators. I would not wish a successful open source project on anyone I love. So I asked Reddit. Always a good way to see what the temperature of the mood of an opinion is. So I recently made the observation in a Reddit thread that it's utterly wild that I can stream myself on Twitch reading an open source code base and commenting on what I think is good and bad about it, and people will happily support me and donate to me for reading someone else's work that does something useful. But the community is so wrong-headed that if the person that wrote the thing tried to charge them $1, they would try and crucify them. Right? Absolutely asinine, unequivocally poor decision-making. So the comments I got were wonderful. Oh, so you hate GCC and Linux too, since they're developed by and for companies. Well, I didn't say that, but fine. If it's free, why wouldn't it be free for everybody? This includes organizations. I'm honestly not clear what you're suggesting specifically and logistically, or fair cop. So obviously I was downvoted into oblivion because I dared to suggest that, perhaps multinational corporations should pay you for your work. It's a wild idea. And also, I don't think that software freedom is as good as freedom from exploitation. Again, I wouldn't say that's a controversial thing if I said it in a pub, but don't say it on Reddit. But the truth is, I was more astonished by people suggesting that charging for software was somehow in contradiction to the original ethos of open source, which was all about software freedom and basically just showed what a fundamental lack of literacy in what free really meant in free software. So I want to tell you a story. So I obviously look like a bit of a stereotype, so we're going to go with it. This is Metallica. You might have heard of them. Lars Ulrich, the drummer of Metallica, was right. So in 1999, Napster heralded the popularization of peer-to-peer file sharing networks, and Metallica litigated. They took them to court, and they were absolutely crucified by the heavy metal community for daring to sue the thing that made music free. So the music business had become this corporate fat cat, nickel and diming everyone with exorbitant prices for CDs. So for anyone that wasn't 19 in the 90s, like £20 a CD when £20 was like £50. And, bands were filthy rich and record executives even more so. And, we all cried, what on earth do Metallica really know about any of this? They're rich already. We just want new music. So I spent my teenage years pirating music on Napster. And Kazaa and Audio Galaxy and LimeWire and Direct Connect and anything that I could steal music from, I stole music from. And you know what? If anyone had actually listened to what Lars Ulrich had actually said in the press at the time, they'd realize he was absolutely 100% correct. And in the 2 decades since, he's been completely vindicated. So, here's the thing. I read an interview with him recently where he looks back on that time where he became like the internet's most hated musician. And he's really, really thoughtful and reflective about it. What he actually said at the time was this: we're devaluing the work of musicians. It doesn't affect me, but it will affect every band that comes after me. I'm already a multimillionaire. File sharing devalues the work, and once it's done, it can never be undone. And he was right. After 1999, the music industry was never the same. Small touring bands that would make comfortable livings scrape by in 2024. Niche and underground genres, while more vibrant than ever, can't get the financial means to sustain themselves. It just doesn't scale. We devalued the work by giving it all away. And when you give it all away, the only people that profit from it are the large organizations that are in power. Spotify today occupies the space that music labels once did, a vastly profitable large organization while artists figuratively starve. There was a news article that went out this afternoon that said in the whole of last year, Spotify paid $750 million into the UK music scene. Does that not seem like a really small number for one of the most famous countries to ever produce music? Hi. Sorry. I wish I had the fine wine and art collection that Lars Ulrich did to ride off into the sunset happily, not really worried about people taking everything. But I feel like I'm standing here desperately hoping that people listen to this message because we are here right now as technology people. This is the moment, I love open source, just like Lars loved the tape trading scene and the underground music scenes in the ways that, that we allow it to shape our culture. Right? He grew up trading cassettes of heavy metal bands. That's where Metallica came from. I grew up trading software for free with people on the internet. That's where our technical culture came from. But, the truth is we're allowing it to be weaponized against us, and it's kind of a violence. It puts humans and maintainers and creators anywhere but the center of it today. What we need to do is find a culture that puts organizational exploitation on the side and not at the core goal of a movement. So we all made this kind of tragic mistake in thinking that the ownership model that could scale between people in our local computing clubs and internet message boards would scale to planet-size industry. But the two things are not the same. They're not equivalent. So here's the most scary part, though. The scary part is how we got here. And, you know, we got here because this is what we wanted. And this really hurts me, honestly, inside. I did this. You did this. Maybe some of you. Depends on how old you are. We all made these mistakes, though. You know, I spent a lot of the last decade and a half advocating for the adoption of open source in mid to large size organizations. It seemed like a really cool thing. I, myself, sat and wrote policies suggesting that while we needed to adopt and contribute if we could, largely organizations never do contribute, to kind of open source software, both strategically and for marketing benefit, that we really should only look at permissively sized software, licensed software, because GPL software, oh, well, we'd have to give loads of our own stuff away and that'd be bad. I wrote that. You know, I did it. And, you know, I was wrong. I was dead wrong. The whole time I was wrong. And what I should have been doing instead is spent time advocating that we licensed dual license software, and that we bought support contracts, and that we participated in copyleft software and gave something back to the community and published our own works. That's what I should have been doing. And I was wrong, and I'm sorry, and I feel like I kind of let everybody down, honestly. But here's the problem. It's not just me, right? It's not just David let the world down by convincing a couple of companies to steal some software. However funny that would have been. Every time a small organization or creator tries to license their software in a way that protects them from exploitation by big business, like Elasticsearch or Apollo, or remember that time recently when Terraform tried to make some money and everyone basically toppled the company, so they had to sell it. Interesting. The whole internet community savages them. You know, we pretend like they've done some terrible crime, but all we're really doing is hitting ourselves, right? We're punishing our peers. We need to be better at supporting each other, at knowing whenever a creator cries burnout, or they say that they can't pay their rent in kudos, or that they need to advertise for work in a fucking NPM package, that they probably mean it. You know, honestly, that they could easily be you, and it could be you, and it might be you next time. Right? This is real. We need new licenses. We need a new culture that prioritizes the freedom of people from exploitation over the freedom of software. I want you to get paid. You know, I want you to have nice things. I want you to work sustainably. I want a world where it's viable for smart people to build beautiful things and make a living out of doing it because it's something they care about. Like, if we have to operate inside this horrible late stage capitalistic hellhole, I kind of want to do it on our own terms, honestly. Now, the interesting thing is it isn't just a single contributor problem. You know, the development community has this misaligned idea that the trust relationship it has between smaller ISVs and itself, you know, is continually conflated with people's love for free consumption software, right? And open source vendors suffer the same outrage as independent maintainers do all the time when their expectations are not met. So there's kind of an idealized romantic relationship between yourself and your favorite free software vendors. And when they reveal themselves to be people, it kind of collapses. You know, last year it flared up, particularly in the tools space, in the very, very, very closed source Postman tool, right? And Postman is really good at having bad developer relations these days. It's one of the things that they're best at, I think. So Postman's like an API testing tool, which has marketing brochureware on its website about its open source API philosophy, which, if you're taking notes here, isn't really a thing. Open source API philosophy. Interesting. Great words. And what they did is they changed their licensing model for the more expensive to be more expensive. And that resulted in a mass migration to a competing open source tool called Insomnia. They've since repeated this every year since, I think, basically Postman have. So Insomnia obviously swiftly changed their own licensing to match Postman's, because they realized that they also needed to require logins and have people pay for them because they couldn't afford to run the servers of their free tool when their free competing product became the dominant one for a week. You know, the mere thought of Insomnia trying to walk towards monetization and sustainability was enough to turn the noses of users conditioned to get everything for free. Now, it's not just API tooling though. Like a similar predictable pattern has happened to HashiCorp. The darling of free DevOps tools everywhere. They changed their licensing, resulting in forks, and a flurry of support from companies that had never contributed a thing to Terraform in their lives, yet actually their entire businesses were dependent on it. We're a few months later from when I originally wrote this slide, and it's funny that HashiCorp finally decided to just get off the ride. And you know what? If I was the founders of HashiCorp after 20 years, me too. So can companies do a good job here? Can we ever ethically interact with open source? And I think absolutely we can. And I think we've done a lot of the dark. Let's talk about the light. Like how do we get better? And I think we need to do a few things to address this imbalance of power between creators and organizations. I think there are companies that do good work in the open source space and fund it well. They all have reasons for doing so. When you look at Microsoft, the card carrying example where everything is basically free now, mostly it's marketing, right? But it's okay. They're the biggest company on earth. We can take their free things that they're paying for, right? That's an exchange of value. I mean, the truth is you are the product when you interact with it, but so be it. If we're going to interact with organizations like this, there's nothing wrong with taking and using the software they make available for free while remembering your patronage is always product. And even the projects that you may perceive to be independent, like, okay, who pays for Linux? Basically Intel and Microsoft and Red Hat and a couple of other companies, right? Right. Linux isn't like some panacea of free. It's a small team of people that get paid and a large set of contributors, right? Like you got to really be mindful that even the open source software that seems like a success has a lot of invisible funding structures that are there to support the thing. Pop quiz. Who pays for Firefox? Anyone know? Google. Why do Google pay for Firefox? Antitrust. Right? Firefox exists at the behest of a large organization wanting a dominant marketplace with Chrome. It's cool. Like we get something from it, but it doesn't come for free. So how do we change this? Well, we need both better approaches and better systems along with the cooperation of all the major vendors to make a dent in this problem. And it's not easy, but there's a role in it for all of us. So firstly, this is the easiest thing, the most free of all the ways that we can solve this problem. The next time each of you is about to send a shitty tweet because Docker Desktop made delaying updates a paid feature, perhaps for a second, don't. Like just for 1 second, think why they might be doing that. The next time you see a library you like adopting an open core model where licensing all of the value-added features exist as a paid upgrade, consider paying for the features. Very simple. You all get paid. Whenever a maintainer asks for support or contributions on something you use, contribute back. Don't be entitled. Don't shout down people in Reddit threads. Don't troll your peers for trying to pay their rent. If we all behaved like this, I think software would be just kinder when we all realize we're all in this together. I think we also need to rehabilitate package management. I think it's table stakes for the next iteration of software and package management and software platforms to support billing at a point of consumption. I would move to a platform that put creator sustainability at its heart in a moment's notice, even if the ecosystem and programming language was worse. I have a theory that more organizations would pay for software if there were existing models that supported and allowed it. Most projects couldn't issue an invoice if they tried, right? It's like two people in a back room. But what if you could pay via your Azure bill or your AWS bill? Our next generation platforms need to support this for creator sustainability. So, we're starting to see the first steps towards this with, nascent projects like SDK Bin, which is like a NuGet but paid project that's been trying to get off the ground for a number of years now. And, what we all really need to do is apply pressure to the platform vendors to allow their billing systems to support remuneration for open source users. Whilst I've kind of said that large organizations leveraging open source throughout this talk have their role to play in this, and they are the problem, I think that large organizations aren't fundamentally bad, immoral, or evil. They just operate in their best interest. They're amoral, right? The first platform that lets me sell software components, they can have their cut. It's fine. That's fair. That's help. I think that this will unlock a whole category of software sales that just doesn't exist in the marketplace today. So imagine that instead of trying to work through some asinine procurement process, you could just add a NuGet package, and at the end of the month, your bill's incremented based on your usage, right? And your cloud vendor, you've already agreed to the spend, it's just out your budget. I think it's the best thing a vendor could do to support creators, right? They could create a real marketplace here, one that's sustainable for everyone, not just people reselling their services. And I think the truth is we should keep fighting for free software. Honestly, for each other, for users, for teachers, for our friends. Like I need to double down on what I said at the start. I love open source software dearly. I want it to survive, but we have to understand what got it to a place of success is something that is currently threatening its actual existence, right? Open source doesn't have to be a proxy for the exploitation of the individual. It can be ethical. It can survive this. We can all survive this. I don't want you to, I don't want to take your source code away from you, right? That's not the point of the talk. I just desperately want to have enough people think critically about it, that when it's, your great new idea that you think you can do something meaningful with, and it's you that can execute and make a business out of it, that, by all means, you can give it away to your peers, right? But spare no pity for large organizations that would never consider you, right? Really don't. Spare no pity for large organizations that just want to profit from your work at your expense. We have a word for that. It's called a job. And I want to leave you with this message of kind of supporting the scene and supporting software. Like in music, there's this idea of kind of going to shows and turning up and supporting the scene, even if it isn't the thing that you're really into. And I think, in music, it's because people perceive the music to be part of our cultural heritage. It's, it's our scene. It's the shared place where the art comes from. As far as I'm concerned, this is our culture. This is the culture of people that build software everywhere. So pay your friends for their software and accept it gratefully and gracefully if they want to give it to you for free. Right? The two things can exist at once. And I just want to talk about charity a little bit. So over the past couple of years, as this problem has started to become a bit too big to ignore, we've seen a bunch of alternative funding approaches start to appear. So we've seen people do things like crowdfund projects using Kickstarter to very, very mixed success. We've seen people who operate Patreons for early access to releases of software. And we've seen GitHub introduce sponsorship, and companies notably occasionally throw in like 10 grand here to a random project. And, the truth is, all these things are used as examples to try and negotiate against the point I'm making when I do this talk. And I'll be honest, I often feel really conflicted about it. A long time ago, I worked in the third sector, in the charity sector here in the UK. And at the end of my tenure, I was left feeling like excellent charity never excuses a poor welfare state. Right? And, I applaud creators who are making grassroots funding techniques work for them. Like, please, dear Lord, get paid if you can. But almost uniformly, they're doing this by effectively charging for software licenses and just pretending it's like another thing, right? And, the truth is they're using the language of Kickstarter to sell a software license and the language of Patreon, which is probably like the thinner end of the stick because people don't find it so formal, to try and readdress the balance. And the truth is they come with a lot of problematic elements, though, because when you start to sponsor creators, actually there's this horrible kind of parasocial relationship that forms between the kind of people that sponsor creators of things and the creators themselves. And actually, it often is the foundation of relationships where those creators are asked to be performers more than anything, rather than just producers of great work. And I think it's a challenging kind of bit. I think it's the same thing as, when you look at the way that like local touring bands today are effectively merchandise manufacturers. They sell T-shirts for a living. And if you're lucky enough, they'll play a song while you buy a T-shirt. And I think that's kind of tragic, truthfully. And, frankly, with all respect to Microsoft, GitHub sponsorships are literally the absolute least they can do as the company that owns like the package management, the platform, basically all the bits in between. They own NPM, they own NuGet. Like, for Microsoft to pretend like there's nothing they can do is basically a fucking lie. Companies spending some money on a project is better than spending nothing at all. But in certain cases, it just pales in comparison to traditional dual licensing solutions to the same thing. So in this space, I think it's just illuminating that, reportedly, and I've heard this from a reliable internal source, the early versions of NuGet contained room for payment capabilities in the API that were subsequently stripped out. I think we need more than charity to fix a culture that would do that, is the truth. Thanks for listening to me talk about the health of software in 2024. I hope that was interesting and maybe made you think about something. That was 39 minutes. I don't know what the time is like. I'm going to see if the food over here is here, and I'll take questions if it isn't until it arrives. Do we need to take questions? Maybe we're going to take a few questions. I'm not sure what's going on back there. Tom? Canal. Yeah.
Awesome. Hi, I'm Kunal. I'm one of the devs working in NewDay. So David, obviously agree with a lot of things. Thanks for raising this point. If the libraries have any vulnerabilities, how do we as developers, proactively defend against them? Like, does software composition analysis tools look out for these aspects? And
so when like a library gets compromised and kind of owned by another user, well, I think the truth is one of the eternal truths of open source software that people refuse to admit most of the time is if you consume it, you own it. Right? It's the same as any code that you wrote yourselves. So I think traditional static analysis tools are the only answer, right? You are accountable. Unless you're paying someone to be accountable. We've got someone at the top here.
Hello. So I think I might sound cruel and crude to this, but I knew like 10, 15 years ago that open source will never work for creators, and creators of the open source is probably like creators of any other kind of art. So let's assume a hypothetical situation. If people want to get money, why they don't stop supporting their own package or open source software and say, okay, right, if you like my package and you use it in your own software, just hire me and I will continue work for you. And I know the answer. The company which used that package immediately will switch to another package which has most downloads after this one.
I agree.
They will not buy you as a person. So maybe those people who do open software, they just do it because they like it. They want to show off. They want to demonstrate their skills. But if people really want to get money, they probably would stop supporting their own software and say, okay, right, so this package to modify PDF is no longer supported. Company switches to another one, the another person say, it's no longer supported. And eventually, all of those people will get hired by other companies who needs to use that software, but it's no longer available online.
Yeah, so if I can reframe back to see what I think I heard, you're saying, what if people are kind of doing it because they love it, right? And they're doing the work fundamentally because they love it, not because a company wants to support it. And that's all well and good, but there are so many examples in the open web of someone doing something for fun and sharing it, and then it becoming a key dependency, and then them getting burnt on it. And like the mental health problems alone of having the burden of responsibility of often broken creators, even before they even try and get work supporting the thing. Now, does it matter? Well, it doesn't matter. If you want to give something away and you're wealthy enough that you can live, then I'm very, very happy for you, because the best thing you can ever do in life is to be like born into hereditary, non-working wealth. And I wish everyone could, I wish I could just fuck around and build nice software and give it all away for free. I would love to do that for a living. I probably shouldn't say that in my own office. Yeah, it's difficult. I don't think there's an answer.
Thank you. That was a really great talk, and I really understand your sentiment. But I'd be interested to see your views on if people were using Patreon and things like that to fund their own software. Is there not an added responsibility to the developer to keep it going, even if they no longer like the project, because someone's paid them to do this?
Exactly that. And I think the thing about patronage is it's very like, the old adage of no art without patronage is true. And I think, patron got the name from there, but it's a bit depressing, right? Because it's evoking being a serf in a medieval court where the only way you can be brilliant is if some rich dickhead on a throne basically throws you a few coins, which is a bit of a tragic analogy in my opinion. I think it's an okay model. I think it's midway on a journey to finding something that really works without compromising the individual. And I think a lot of performers and creators are going through that similar kind of boom and bust crowdfunding relationship where it can get pretty toxic because it evokes the entitlement of late stage capitalistic consumerism. Big sentence for you all. Sorry, don't mean to be on a soapbox. Hey, man.
Thanks for the talk. So how do I get a company to actually pay for open source software? I've tried it 5 years ago. I knew the developer who was developing.
Yeah.
We were using it was used extensively across our platform, and I'm like, well, I know him. Can we just throw him a few £100? It's nothing.
Yeah.
It's nothing to us. Can't do it.
I think it's really interesting, right? I think it's the responsibility of people in positions in power. And often, you know what, like all of those times you ever see a large organization pay for some open source software, it's always just some nice person that's working in some mid-level team who has a little bit of budgetary control that's doing someone a solid. And I think, where we can, let's keep doing that, like spend money on people. We love that stuff. I think more structurally, it relies on people having the backbone and the nerve to be honest about this in positions of power. I think is the truth, and we can only be as good an advocate as we possibly can. I am hoping that the vast majority of open source software in the evolving security climate comes with enough disclaimers that basically say, well, we're not really accountable for security unless you pay us. And I'm hoping that'll be enough of the, we've tried the carrot, here's the stick, right? Because then actually what you're doing is you're competing with other for purchase software, and actually there's more value in both software that people pay for but also is shared, right? And I think it takes a lot of individual effort to make that happen.
I might struggle to word this, so bear with me, but I think I wanted to expand upon what the gentleman behind it about Patreon and kind of like supporting your fellow, let's say, like creators. I feel like that kind of takes away a little bit of value from themselves as well. So like, say for example, my colleague here, published a package, or even if it's like in the context of like content creation, it would be like up to me and like people like myself and people like him to support them, and which is like it kind of takes that responsibility away from the organizations, a lot of conglomerates that like you had mentioned at the beginning. So I feel like there is an advantage to it to a certain extent, but then the onus and responsibility comes down to us at the end of it, and it just gives the large organizations basically a free pass to continue to doing what they want. I want to hear your opinions on that.
Yeah, it's dangerous, isn't it? I think the truth is all organizations just exist around people, right? And I think as more people change their fundamental perspective, we can behave more ethically as employees of organizations. I am not ferociously, anti-organization, anti-capitalism even, frankly. I mean, I work for a credit card company. The irony appreciated. I think that the truth is, power dynamics exist and can be dealt with correctly when you understand what they are and are communicative about what they are and explain what they are. And I think that's the important thing. So I think where you have leverage to contribute back as an organization, you should push it into your workplace, right? I've long always suggested whenever people that have either reported to me or worked for me, they want to work overtime, I tell them to go and do an open source project, right? Go have fun. Don't give it away, because you're not playing the game of capitalism, right? If you're giving it away, give it away to your friends. Always.
Hello. Also on the topic of capitalism. So if
just the big bits.
So yeah. So if let's say a package became suddenly more expensive, and it became more beneficial for a corporation to make their own package, to basically copy it. I just wanted to get your opinion on how easy the current regulations and laws would make it for a company to
just rip you off.
Almost to rip it off, to rip off a package rather than using it. Because if it's easy for them to say, oh, it's free, let's use it. suddenly it's not free.
Well,
We can make our own based exactly.
But at the moment, Amazon basically steal everything from any open source project that they like the look of. I'd much rather they got a bloody nose and had to do some work to do it and paid some programmers, because then at least someone's getting paid somewhere to rip you off, I guess, is honestly my feeling. Like at least we're taking back some form of control. I don't know. I think it's a bit bleak, to be honest, and often actually the reason that large organizations will take from small communities is because either they don't have the chops or they've yet to work out how they can buy the community. And, paying you for your time to replicate your work is a fair exchange of value. That's, again, jobs. Jobs are fine. I think the truth is if you take value from the adoption of your package, if it's, it's a bit like supporting a football team. I wouldn't know anything about that, or like loving a band, right? It's not your personality. Your work is not who you are. It's a thing that you do, and you should have pride in it. But if someone else with vastly more resources than you comes and wants to take it or copy it, I mean, good luck versus Amazon, right? Or Microsoft or Google. It's probably not going to happen. So hopefully they'll pay you. I hope.
So I do agree that people should get paid for the work they do, whether it's for hobby or whether it's for making a living. But what about the companies on the flip side who are smaller organizations or non-profit organizations?
Right.
So what we can do for them to actually, they won't end up in a situation where they will have to pay something which they don't have. But
yeah, I would gladly give all of my software away for a charity that's doing good. Fuck it, let them have it. And I mean that sincerely. And there's a complicated answer because obviously charities are complicated beasts, and having worked in the third sector, there's a lot of variance there. But generally, I think, and maybe this is just the bleeding heart liberal in me, if people are trying to do good for people, sure. I think that's kind of in the spirit of the game. I think there's an interesting secondary dynamic that you picked up on there, which is like, what about small startup organizations that often they need open source to get that leg up to make themselves viable, right? And I think, if I was writing a software license tomorrow to fix this, it'd be like, well, if you make more than 2 million quid, or have like 500 employees, fuck you, pay me. Otherwise, please, by all means, take all the work. Hope it goes well for you. Do some cool stuff. And I think that's, as long as the relationship there, again, it's all about power. Those people have no more power than the individual really do. And it's when the power imbalance becomes so great that the kind of the cultural dissonance kicks in.
What's your opinion on a big organization supporting some of the open source project? Because sometimes there are so many open source projects and they die out without anyone using it. So when, let's say, Microsoft promotes some of the .NET based libraries, then other developers start trusting it and they become popular.
Yeah,
so
I mean,
Microsoft, sorry.
I think, please.
Yeah, so if Microsoft separates some resources to contribute to open source project, can it be considered fair?
Yeah, okay, so interesting question. Hands up if you think .NET is open source. Kind of, right? It's an interesting... .NET uses an open source license, kind of. It's open source as much as they will take contributions that don't change their roadmap direction from the community for free. And they will give away the source code because it ensures continuity over time, because it makes people feel good. Open source as a culture? I don't know. I love Microsoft, honestly. I think they do great work, and I like those teams, but is it free? Biggest company in the world? Probably quite unlikely.
Hi, David. Thanks for the talk. I don't want to sound too delusional, but despite agreeing with you that charity or donating to projects or stuff that we regularly use and make our life easier, I don't think it will really make a difference for the maintainers of the projects. But don't you think that corporations and enterprises indirectly fund projects to being developed because they are basically paying people
I think that's the way. Yeah,
So they are empowering them to
absolutely
do this in their free time.
And I think the most ethical way most organizations interact with open source is they pay staff to contribute to it, and that's a good thing. And that is totally a thing that people can do, and it's cool, and I am not complaining about that at all. That's work. Well done. Like, I think very, very good. I think where we need to be careful with the charity angle is charity is a sticking plaster on a cultural wound always. In every kind of, through every lens you look at it, in every different community where it is relevant. And it normally hides structural imbalance. Now, the thing I think that will affect real change is that if more people start to ask the vendors to be able to charge for their software, if more people build middleware, ultimately the rolling rock rolls in and they're like, okay, well, this is a feature that our paying customers want. And, if this makes our platform more attractive, what do Microsoft want? They want developers building on Microsoft software stacks, running in Azure, spending money on resource. Well, if those developers can charge other people for the software that they make, that's a win for everybody. I think it's about
Any
time
other
at the bar.
questions?
Almost.
I don't know if it's a question or a statement, so stop me if I start.
But less of a question, more of a comment.
So I have the luxury or unfortunate history of being a failed lawyer. So I tried to become a lawyer once because I didn't want to be a software engineer for too long. It was a road to money, I guess, and wealth. I failed. So when you talked about Metallica and Lars Ulrich, it took me back to the noughties and DVD John Johansson and DCSS. And really, at the time, it was a copyright question, wasn't it? So does a company like, or an organization like RIA, does Metallica, do they have the control over you in your home? Can they stop another company coming in and allowing you to transmit information between two private parties? And I recall that all being about whether corporations should control what people do in their own homes. So you talked about...
It's a very, very American story, isn't it, when you get to America? It's about freedom.
I read Free Culture by, who is it? It was the guy that ran for president a while ago. It was another lawyer, funny enough. But the whole thing's there, and it's also laid out as, in the freedom of your own home, shouldn't you have the right to give someone an MP3? Shouldn't you have the right to cut a DVD or trade a VHS? And should that really permeate our lives? Because open source has always been about the freedoms to do things. And I think it might be more of a licensing question to music at the end of the day.
I think it became a licensing question, but I think fundamentally, here's the, and we're seeing this, obviously, hashtag current year, rise of AI, whatever, the death of all creators, is do you want to live in a world where everyone that ever does original, interesting work gets shat on so that there's no more original work? Right? And in 10 years' time, where does the next generation of people doing interesting, innovative work come from if all of the journeymen in the middle that would have taught them and showed them the path have been basically made destitute and are doing other things now? I don't want it. It's not good enough, Awesome.
Any final questions? I think that might be it then. We're just going to take a short break.
I suppose I should say NewDay's probably always hiring, and I'm really nice to work for, and I'm not always this negative sounding. Don't worry about it. I'm a good laugh.
Thank you, David. We're just going to take a short break. Feel free to pop to the loo or grab some food. There are some pizzas on their way as well. Feel free to help yourself some more drinks as well.
infinity and back again. On to them. Young dog and I talking. You know once in the shine, don't vex when you get married. Me nah make trouble stress my brain. Cut checks me, I cut to the chase. Star never second hand, never second in command. Never stopping for a second, talking up on the line. Look a jump and sound, I got Have you heard the new song for More Plastic? Well, here goes.
Hi all, hope you're doing well and enjoyed the food and the drinks. There's still a few left over if you still want to keep helping yourself. But I'll just keep it short and sweet. So I'd like to introduce Ian Cooper, if we can get around the call, please.
Hey everybody, it's really good to see so many of you here. As I said, my name is Ian Cooper, as discussed. You can find me in the various places we've all kind of like spread ourselves. Used to say, I'm on Twitter as iCooper. Now it's kind of like, I'm on Twitter, I'm on HackyDerm, I'm on LinkedIn. We are diverse. Who am I? I've been doing this a while, as you can tell by the grey color of my beard. Most of that's not that very interesting. I've just worked in a whole lot of places. The point I care most about is the one kind of on the bottom, right? It's very easy, I think, sometimes to feel people who stand up and talk, they do that because they're brilliant or something. I'm not, I'm just like you. I'm very lucky in when back about 2002, I started the London user group. Dylan Beattie kind of runs it day to day now. 2002.NET was in beta. So there were no experts to come and speak. There's no presenters from Microsoft or anything. No one knew anything about it. So we literally had to say, okay, who's going to do something next week? And you'd kind of volunteer, because around the group I had to volunteer quite regularly. So I got very used to standing in front of people and talking about stuff, right? And once you get over that fear factor, it's okay. And you all have content, right? It's stuff you know. You are the content. If you get into it, you can get to travel the world and go and speak at conferences, and it's an amazing opportunity. So I'd really encourage you all to have a go. I work on an open source project called Brighter. So after David's talk, if any of you want to just give me some cash afterwards, there's Paul over there, there's another maintainer as well. Feel free to basically just cash or Bitcoin, and maybe I guess Paul. I don't think anyone else is here. Gordon, did you ever push any code to Brighter? I can't remember. It's a shame, because I don't want you to believe that you had to have a beard to contribute towards Brighter. But we do welcome contributions. If you ever wondered how can I contribute to an open source project, we're very friendly. Transports are a great way to start. So by transport, we mean we support things like Kafka, Rabbit, SQS, Azure Service Bus. If you want to add new ones, feel free to come and talk. This is a great place to start. All right. So some links for later on, or for now, if you're worried about being able to see things, you can get the sample code on my GitHub repo. You can go and get Brighter from GitHub there. It's also obviously a NuGet. And you can get this presentation from GitHub as well. It's called Kafka for .NET developers, somewhat obviously. Taking photos who wants to? Right. What are we going to talk about? We'll talk about Kafka, right, a little bit. We'll say what it is, explain why you might want to use it. We'll talk a tiny bit, but in the interest of time, only a tiny bit about the management of Kafka. I need to kill the echo. Oh, ignore it for a second. Then we'll talk about basically using the C#. We will look under the hood a bit to answer some questions that will then come up when we talk about making things more reliable, both in producers and consumers. We'll delve a tiny bit into this weird and wonderful world of Kafka and deserialization and serialization, in case you come across it. We probably won't get into Brighter because we'll have run out of time and you'll want to get on the pub. There are slides in here we'll skip over because there's a whole 1.5 hours if you want it sort of thing here, but we'll just skip over a few and make it a bit easier. All right. So Kafka was created by Jay Krebs, Neha Narkadi, and June Rao at 2011, and they worked at LinkedIn. So for those of you that ever think, what is the point of LinkedIn? Well, at least they gave us Kafka. And they had enormous amounts of data. So typically, a whole load of the areas at LinkedIn were creating data, putting it in local data stores, and they were data engineers, and they wanted to go and basically put it in their data lake so that people could analyze it. And they realized that every single thing they had was kind of a unique integration. And they said, well, this is crazy. We're maintaining all these unique integrations. Can't we just build something that will let us suck data from whatever source it is and put it in a new location for us? So they came up with this idea, effectively, of an append-only log. So they have a producer. The producer essentially appends new records into a file, and then consumers can just read the file. And they do so in a non-destructive way. In other words, basically by consuming something, you don't delete it, you just advance your pointer into the file, right? Kind of stuff you probably did when you were first learning to program, when you started reading and writing from files and appending to them. And it's fast. Because it's an append-only log, it's pretty fast to read from this, and it's pretty fast to write to it. There's no modification of the data in between. And because the producer is effectively writing to disk, and the consumer can come along anytime in the future and read from it, we have an asynchronous conversation. right? An asynchronous conversation, both parties don't need to be present at the same time. You and I tend to call asynchronous conversations mediated by some kind of stream or queue messaging, right? But under the hood, what Kafka is doing is just this model. So to use Kafka, the first thing you want to do is have a producer, and the producer is going to write stuff. And what happens is you want to write what's called a record, and a record effectively has a value, the data you want to share with somebody else, and a key. Come back to key a bit later. We'll explain why key is important. And essentially your producer says, okay, I'm going to turn this into a record, and then just appends it to a log. And we identify different logs by saying, what is this about? We call it a topic. So we say, hey, this particular log is about this. That is the topic for that log. And a consumer just reads from that log. And it reads in order through the log. And as it reads each record, it needs to know, I read that one. Remember, it's not destructive. So if it crashes and it needs to restart, it wants to know how far it's got. So it needs to store what's called an offset. How far have I read into that log? And what we do in Kafka is we use Kafka itself. So you write to another topic, how far have I read into that log? In case you crash, you can restart and then you just resume where you read from. Okay. Because I read effectively this log and just produce offsets, I can preserve ordering. So one of the real nice attributes is I can read things in an ordered sequence. Obviously, one of the implications is, though, it's non-destructive and I'm reading in sequence. So effectively, I get one reader, one thread. Because otherwise, I'm not reading sequence, right? And if multiple things try and read, well, how are they going to adjust the offset? So I can only have one thread reading. And the obvious question may be then, Ian, that's not going to scale very well. Should we just end this whole talk and go to the pub? Because I've got like 100,000 records a second and I'm not reading them on one thread in sequence. That's where we get to partitions. So the idea is we split this topic up into you can think of them as a number of different files, where effectively each one of these is effectively an append-only log, which we're going to write to under the same topic. And then what we want to do is make sure that when we distribute the records into those partitions, anything that essentially I need to read in sequence goes to the same partition. And that's what our ID is for. The ID says, hey, anything with this ID needs to be on the same partition, be read in sequence. So you might just simply use the ID of the thing itself, right? So I work at Just Eat Takeaway. We might basically use the idea of a restaurant. And there's an algorithm called consistent hashing. And consistent hashing just says, whatever the ID value is, allocate it to the same bucket, to the same partition, right? So they've got 5 partitions. It will allocate them amongst the 5 partitions and do so in a consistent way so that 1, 2, 3, 4 always goes to the same partition. So that allows me to effectively write to a whole range of partitions. So I calculate the partition from the key, right? And then I just write to the relevant partition. What that means is I can have multiple consuming threads. Each one of those threads is going to read its own partition. And that way, I'm effectively scaling. The more data I have coming in at speed, actually, the more partitions I'm going to need in order to make sure that my queue is not growing too long. I haven't got too much latency, right? So I have to have more consumers and therefore more partitions. You can use a thing called queuing theory. I'm not going to get into that tonight to figure out how many partitions you need, right? It's this idea effectively of being able to predict if you were at a busy bar, how many people you need to have working behind the bar so no one waits too long to get served. All right, so it's the same principle. And each consumer, effectively, what they're writing is actually not just the offset, but the offset for a given partition. So what is my progress on a given partition? So we said, so the thing to bear in mind here is only one of these consumers can read from a partition at any one given time, although a consumer can read more than one partition. You just have a max of one reader per partition, and that's otherwise we're going to lose the ordering, right? So there's an idea called consumer groups, and a consumer group says for a given consumer group, divide up all the partitions that you have amongst all of the consumers that are in that group. So if I have 3 partitions and I have 2 consumers, someone's going to get 1, someone's going to get 2, right? If I have more consumers than partitions, some of those consumers are not doing any work. They may be useful to you for one of my consumers crashes, this one can immediately take over. So if I've got really high throughput and I want to make sure that I don't basically build up latency while I'm restarting something, I can have an excessive number. More commonly, you're a bit short of the number of partitions, right? So some people are doing double work. But you can scale up or down the number of readers as you want. Number of partitions is much harder, right? Number of partitions is actually quite a big choice. You can scale up partitions on the fly fairly easily, but you can't scale them down. So we tend to try and think about partitions as part of our design process, and then we just scale up and down consumers as we need them. Read that set of partitions. If I have 2 applications and they both want to read all the data, they're just 2 different consumer groups. Each consumer group will maintain its own position inside that particular append log that we need to. All right, just a review. Producer writes a value to a record, writes a key. The key is used effectively by consistent hashing to allocate it to a partition. We have a number of partitions depending on effectively how much we need to scale a given topic. Consumers read from the partitions. A given partition can only have 1 thread reading from it. A consumer may read more than 1 partition if it needs to. The consumer group is the number of, is basically allows us to determine who should we divide the partitions amongst for a given application. Offsets record how far has my consumer read on a given partition, so that if I crash and need to restart, I can resume from where I left off. All right, I shall just take a moment for you to basically stare at that diagram, because that is Kafka. Once you get that, you understand how Kafka works. Kafka is not a queue. Queues, which are things like SQS, RabbitMQ, etc. Queues are destructive when you read it. When you read from a queue, you take the item off the queue and it's no longer there. They have different use cases. Streams are really great for pub sub. I want everyone to know about something. Queues are great for tasks. Once I've done it, nobody else should ever try and do it again. All right. Kafka is a streaming technology. There is, I can't work something like a KPI or something, or a KIP. Kafka has a name for them, but there's basically a proposal for adding queues to Kafka. You will find some technologies, Pulsar, NATS, RabbitMQ now, I think, support both queues and streams. I won't bore you running Kafka and Docker. It's painful. All right. We'll come back to some of that later. Okay. Managing Kafka. So Kafka comes with a set of command line tools, which runs on the left-hand side. And generally, the way you manage Kafka tends to be with command line tools or with a UI. We'll see the UI in a second. But obviously, you want the command line tools if you're doing any kind of like automation, essentially. So you can do things like create topics, delete topics, check for offsets, that kind of range of options. You can set up your broker so that if you try producing to a topic that doesn't already exist, it will auto-create it for you. It creates it with a single partition. It is great for local development. It is not what you want to do on a production system. So generally, you'll be using this on a production system. There is an API for Kafka. So you can talk to the API and you can automate setting up topics with a high number of partitions, etc. So Brighter, for example, can do that for you if you ask it to. Ask it to create basic topics for you. It will create topics and it will talk to the API. Generally, most people have essentially got their infrastructure being built by something like Terraform, Just Eat Takeaway. We take async API. We use Pulumi to actually basically build everything out, right? So generally, you only want to do that for local development. There's a really useful tool called KCat. So KCat, or used to be called Kafka Cat, is what they call basically a non-Java generic consumer and producer. What does that mean? It means you can just send stuff from the command line to a Kafka topic, and you can read stuff off by the Kafka command of a Kafka topic. If the body of your Kafka message is just JSON, right, it's really easy to have a look and see exactly what records you've got on a given topic and interrogate stuff. Very useful for diagnostics. I still believe it's quite possible that you could just take Kafka, KCat rather, and JQ and write a whole suite of applications, but I'm not bold enough to decide that is a thing. All right. Stuff I know. All right. I won't do a demo on CLI tools. For UIs as well, we'll see one that's very hard to read. This one is basically Kafka UI. There's a whole set of them. AKHQ, CAFDrop lenses, CM4K are free ones. Confluent and Conductor have paid ones. They're all pretty okay. I'll come back to that. I'll just show it as part of doing a demo later. All right. So I see most of you are .NET developers. Anyone not a .NET developer and just sort of wandered off the street by accident? Okay. Yeah. All right. Hopefully most of it will make sense. So I need to build a demo application, right? And I want to show producing a message and consuming a message. So because I got bored of Hello World, I decided to do Calvin and Hobbes. Who knows who Calvin and Hobbes are? Gosh, I feel old. Calvin and Hobbes were a cartoon strip used to run in newspapers. Calvin is a small boy. He has a stuffed tiger called Hobbes. Most of it takes place in his imagination. So in his imagination, Hobbes is a real tiger who is his companion. And Calvin has the transmogrifier. It's a cardboard box. But on the cardboard box, he has transmogrifier and there's a couple of dials. He can decide to be transformed into something. So eels, worms, things like that. And in various stories, he is transformed by his transmogrifier. Right. So we're just going to write something that basically as a CLI lets you effectively create a transmogrification and send it via Kafka to something that will do the transmogrification for us, right? Just because it's slightly less dull than Hello World. Okay. So how do I produce a message in C#? So this little dispatcher class, we'll see the code at the end, is going to do that for us. And what it's going to do is say, okay, I need to know about the topic. It's just a string which identifies effectively what logs I'm effectively writing to. I need some config. You probably can't read that. All it says is bootstrap servers localhost 9082. So what it's saying is, where is Kafka? Right? I need to talk to a Kafka broker. Where is it? It's called a bootstrap server because there's underlying all the non-Java clients. There's a thing called libRd Kafka. Java is basically native. And libRd Kafka does a lot of work for you. One of the things it's going to do is get a hold of the metadata from the server, which tells it things like, where is your topic going to live? So it can then talk to the relevant node in the cluster that basically it needs to do its writes to, right? But you can ignore all that. You just need to tell it where is the bootstrap server that will give you the metadata. Then what we do is we have to build a producer. So here we're saying string. What does that mean? It means the key is going to be a string and the value is going to be a string. Notice we can effectively use .NET types here, right? We'll talk about that a little bit later in serialization. Brighter actually uses string and a byte array because it just turns everything into a byte array so we can have a generic format, right? But string will work for our demo. What we do is take the builder, we build it, and we create a producer, right? And then effectively to produce, we just call produce to the topic and we write a message. And the message is string, same as the producer. So a string key and a string value. And we're going to basically say, what is the transformation that effectively you want to do, all right? Then at the end, we're going to flush. Why are we going to flush? We're going to flush because Kafka is asynchronous unless you use the async method. Okay. So Kafka is async because what it's going to do actually is put that on a queue, and a thread is going to effectively read that queue and post the information to the broker. If you use async, you're going to force it to wait. It's weird. Just use the produce, right? Unless you are forced by, viral nature of async to basically use the async one. Okay. But you want to flush because maybe stuff left on your queue at the end when you shut down, which may not be sent to the broker yet. You can get a return value from the flush, and that will tell you how many messages remain on the queue. So you can do a loop which says, while it's not 0, keep flushing and tell me an exit in a certain number of seconds. Tell me how you're done. All right. And tidy up. Yeah. Okay, consuming message. Okay. So we're going to consume from a topic. So we're just basically saying what is the same topic we're consuming from. Consumer config is very similar. Bootstrap servers. We're going to have a group ID. So remember we talked about groups earlier. We want to have a group ID which says to us what is the group we belong to, so we can track offsets against that group. And similarly, we'll create a consumer builder. Similarly, we're saying that the message has a string for a key and a string for a value. We'll create a consumer, and this run method's going to take a couple of parameters. It's going to take a translator and a handler. So what we're doing is we're passing in some functions to say, when I get a message, I want to translate it into a .NET type. When I have that .NET type, I want to carry out an action. We're just going to run a message loop that basically lets us pass in those items. So in the actual body of that particular function, we're going to say subscribe to the topic. So that just means, hey, I need you to go and get the metadata, and I need you to basically figure out where you're going to read from, et cetera, et cetera. So it's basically just telling Kafka you need to do some Kafka stuff with a client. And consume is going to poll and get us essentially the next message off the queue. If we're EOF, it means there's no data on the log that we haven't already read, so we tend to pause. And then we'll use that translator function we passed in to take the body and turn it to something useful, and then effectively handle that. And at the end, we will then close the consumer. Yeah. Right. Yeah. And message pumps tend to be a while loop like this, right? And this will effectively, when it hits the cancellation token, effectively that will basically break us out the while. That's already message pumps do. If you want to know generically what message pumps do, they're a while loop. They do a get message. They translate the message. They handle the message. They move on to the next message, right? Windows is basically the heart of, say, a Windows system is a message pump, taking events from the mouse or whatever and directing it as messages, which then spins around and reads stuff, right? Any of you .NET programmers ever seen that thing, STA thread, and wonder what does STA thread mean? It means it's a message pump. It means effectively things are arriving on a message queue, and essentially it is dispatching those on a single thread. Brighter uses a single thread, right? Uses a single thread, it's what's called a reactor model, or a proactive model if you're async, and then you just increase the number of threads. If you use a thread pool, you will get thread pool exhaustion. If you use a semaphore, your semaphore will eventually crash. But don't use those, basically. All right. Okay, that's the whole body. Very hard to see, but the run method effectively where it does all that work. All right. And to use the consumer, we're just going to pass in this information, set up a cancellation token, and cool stuff. All right. Topic we want to consume from, where is Kafka? And then effectively we're going to run our message pump. Talking about this stuff. So we're going to use console.spec to make it look nice, but don't worry about how that works. And in the run, we're going to pass in a method that says, hey, take the message and turn it into a transmogrification as that key and value. And then it'll handle that by printing that out to the screen. Right. That's the C# consumer. All right, let's see that running. What happens if I try and change the window? Excitement. I will try and make it a tiny bit bigger. Ian. Going to become a frog. It is error trapping actually because I spelled it wrong. So actually, I'm doing demo 9. You don't want to see all about schema registry yet. That's spoilers. Probably got 2 messages in the pipe. So what's happened is basically I've sent a message, and you've got to see Kafka UI around. Kafka UI. Since we've got a broker, it's got topics. There's a whole load of topics. I think we're probably calling it something like transmogrification made. Transmogrification. All right. And then in fact, we can see that there are messages. You can see that we've effectively got some messages waiting to be consumed, like worm and eel. Right, so you can see what's going on there. And if we run .NET Run here, maybe more than one at this point. Yes. Yeah, because I ran it on another schema thing. That's why. Verb and success. So it's just, as you can see, I am. If I do it again. So before you can see that when I did it, I could have a delay in between. All right. I could send it, come back a bit later, go and look at the UI, just sitting there. It's an asynchronous conversation, right? Using the messaging in between. Yeah. Right, and you can see. All right. A little bit, just so you can see the code in case you were clear. This is demo 2. That's what code we're running. See the produce, basically produce a builder, then produce, send the settings across. Program is already just saying set up the UI that we need, and then effectively run basically the dispatcher to send the transmogrification we set up. And in the you can see the message pump we talked about earlier. It's just doing this big while loop. Subscribe, consume, check what we've got, and then translate it. Right, and that's the basics of getting Kafka to work for us. All right. A little bit about how does Kafka work. Let me just keep an eye on time. I'm all right. So generally, a Kafka broker, it runs in a cluster with a number of nodes. Generally, there's an odd number of nodes. We'll explain that that's just to do with basically being able to do elections and stuff. Your data is written effectively to a leader and a number of essentially followers. So you always write to the leader, and then the broker itself will copy the data to the followers. So in the event that my leader node crashes, one of the followers can take over and become the leader, thus effectively giving us resilience against failure. The leaders are obviously not all on the same node, so they're distributed across the nodes. And one of the brokers called the controller will determine, looking at the balance of where work is, which node to assign a leader to when you create a new topic. The Bootstrap server is the one that you talk to give you the metadata. Metadata tells you things like, okay, where is the leader for this partition? And then you basically talk to the relevant broker in order to actually write or to read. Once upon a time, Kafka made you read and write from the same node, but nowadays you can actually write and then read from others. There are some consequences to read from others, which is eventual consistency. In other words, they may not have caught up, depending on how you configure your producer, which we'll come to in a bit. Don't worry if you don't get this bit, because it's redundant mostly. So who decides who is the controller? The Kafka node in the cluster, which is going to determine who are the leader partitions are, right? So originally Kafka, it may well be in installs you're using still, has to effectively rely on an external system, Zookeeper, for leader election. So Kafka itself didn't support any mechanism to do leader election. So what Kafka would do effectively is create something called a virtual node in Zookeeper. And the way the virtual nodes work is essentially, provided you are consistently essentially trying to basically set that virtual node, it exists. If not, effectively it closes down when the socket collection, when the connection to Zookeeper goes. So all of the nodes say, I want to create it. One of them wins. That one becomes the leader. Everybody else is kind of sitting there waiting for that virtual node to get deleted in the event that you crash and the socket goes with it, right? So it uses Zookeeper for that purpose alone, which is essentially leader election. It used to use it for more in the past, but that's all that's left to it now. Modern Kafka, and I think it's about 3.4 since, basically supports implementation of the Raft consensus algorithm called Craft. People are so original. And Craft effectively lets them do leader election amongst the nodes themselves. And you get a bit more choice, right? You can opt for roles. I can be a controller, or maybe I'm never going to try and be a controller. So if you are a controller, you're saying, hey, you can choose me, pick me. If you don't choose to be a controller, you can just be a broker, or you can be both. Right? So when we write to the cluster, we can tell the producer what level of fidelity we want, and therefore how long it's going to take to succeed. So we can be really bold. We can just say Ax is 0. What that means is I got a connection to the broker, but I don't really know whether or not that actually got written at the far end. You know what? I'm just going to take my chances. And that's fast, because essentially all you got to do is essentially put the message on the socket that from your client and then walk away. Right. It's also very likely that your message never reached Kafka and you're going to get gaps. This is okay with stuff where effectively you get a lot of messages and the next one's probably going to replace it, like position of a driver for Uber, right? I'm going to continue to signal these things. I can drop a few. Ax equals 1 says, that's a bit bold for me. I'm going to make sure it's at least written to the leader. Right, and I'm going to rely on Kafka in the background. It's going to successfully copy that to all the followers. I'm not going to wait around for that. I trust Kafka to do that for me. And I don't want to read from any of the followers, so I don't care whether or not the followers effectively have got the data yet, because I'm always going to read from the leader, which means it's always going to be consistent. Ax equals 1 is a bit of a compromise between consistency and efficiency. Or you can say Ax equals all, and that means, hey, don't tell me it's done until you've written to every node in the cluster. That's what you want if you want to be sure you're not going to get data loss, right? So for example, effectively one of the nodes gets lost, your leader gets lost, another one gets promoted. If you haven't got Ax equals all, it's possibly promote something that hasn't seen all the writes yet. Okay, so Ax is all is your commitment to I cannot lose data. Kafka will basically monitor what the latency is in terms of a follower being updated. If a follower gets too lazy, then essentially that takes too long to update, which could just be it's crashed and dead, but it might just be there's a problem with the network to it, etc. It will declare it to be an out of sync replica, take it out of the cluster, which means essentially that you're still reasonably efficient at writing all, and you're not being held back by one node that's misbehaving badly, right? And it says that one, you're going to have to administer that back in because it's basically out of sync, right? So how do we make reliable producers? So the key ideas in Kafka are, I want to set the number of Ax. Here we're showing Ax all to make it reliable, right? You can set a number of retries. Don't forget what we're saying is in the producer, there's a queue and there's a thread, and it's handled by the underlying client library. And you just tell it how many times should you retry before you give up trying to send that message on the queue. Retry back off is obviously telling it how much should you back off between retry attempts, right? And the max in-flight request per connection is essentially how many threads will you run to read that queue. If it's anything more than 1, you don't care about ordering. Because if you have 3 or 4 threads, Well, the order that they come off the queue might not be the order you wrote them. So 1 is I care about ordering. 3 is I don't care, right? People do use Kafka in circumstances where they don't care about ordering, just care about schlepping the data as fast as they can, right? So, very familiar from before. But what we're going to do here is a couple of things. First of all, because we are using this libRd client library underneath, it's useful for it to understand what it's telling us. So we can set up a couple of little things that basically are callbacks that say, hey, we'd like to actually know about basically logs, and we'd like to know about errors. Do something very simple here, which is basically logging them out to console because it's a demo. You obviously want to basically add them to whatever your logging system is. The next thing we're going to do basically is we're going to say, when we produce this message, we are going to basically get a callback. And that callback will allow us to know that message was written, right? So if I only got 3 retries, eventually I might give up. And we're going to register a function. Remember, it's basically an async process, right? Because it's basically saying, I will write, it sticks on a queue, threads on the queue are trying to send it for you, you keep executing. So the handler we're going to execute, which basically is just a delegate, we're going to do some work to say, okay, I want to record it's being sent. So we have the world's worst outbox implementation here because it's in memory. And obviously, if the application crashes, you lose everything in your outbox and it doesn't participate in any kind of transaction with your data. But I'm going to call it an outbox anyway. It's just a list of messages that I've sent, right? But the same principle applies if you genuinely had an outbox. What we're going to do is we're going to record in the outbox that we've sent this given message. All right. Say, hey, there's a report saying I sent the message. So I know that message was actually sent by the producer. And if I had a genuine outbox in an application like Brighter supports, I could have something in the background which would say, hey, it didn't get sent. I should resend that one. All right. So we're effectively going to say, hey, there's a message to send. Hey, that message was sent. Right. And then we can effectively see the results. That's all that code. We'll come back to that in a second. So this is the async thing. You can basically use an async method, produce async, right? The thing about async is it means you're not async. Yeah, I know. I didn't write it. It's not me. But yeah, in principle, at scale, the throughput of async await is lower. Right. For those of you that just add async to everything going, I'm going to put async on, it will go faster. Not true. Okay, so we're going to show you how to show you reliable producer in action. Let's do the demo, and then we can look at the code slightly again. This is a little bar to me, a slightly irritating bar where I want to. The same story. Okay. Right. I've sent in the bug, and what I'm going to do is see this. And what we basically asked. Output that outbox result, just so you can see it. So what it's saying is, hey, you wrote that, its status is now persisted. So we can see the messages we actually sent, right? I had this happen before and I can't remember why it does it. It's a really simple thing, but I can't remember. Okay, I can't. There's a fix for that, and I can't what it is. We'll move on. You've seen that running before, but I can't remember why that stalls. Okay. Looking at the code, demo 4, I think. Just to recap. Yep. So you can see effectively we've got this callback. Delivery report is what essentially the client will send you. The generic parameters here are just the parameters basically for your message. And we're saying mark the status in the outbox basically is being sent. That's the message. We're going to send the message, but first of all, we're going to commit it to the outbox. We have a message unsent in the outbox. When we get the delivery report back, we mark it as being sent. The outbox is not particularly spectacular, I promise you. It's just like a list of entries, some helper methods. And the program, all we're adding at the end basically is we're saying display the status of the messages in the outbox, right? And the consumer is pretty much as before. I think we may have some stuff in here, additional stuff. Yeah, we'll come back to about resets and everything else in a second. All right, let's move on with the code. Okay. It's just confusing, I think, early on. So we'll come back to that. It's really mainly used for streams, so don't worry about it. You don't need to worry about that. Okay. About the consumer side. So the important thing to understand about consumers are these flags. Remember that we said that we effectively are going to store our offsets in Kafka. So what decides how that works? It's effectively a number of flags. So auto commit true or false, and auto offset store true or false. So the offset store is essentially saying to the client, I want you to keep a track of all the offsets. Right? Just store them away in whatever data structure you want to use. And the commit says, on auto commit, it says, and I want you to basically, on a thread, every X many milliseconds, which I think it defaults to 500, but you can define, right? I want you to essentially send those offsets to Kafka. So this, essentially what will happen is I subscribe to the consumer, I consume a record, and if I've got this set up, true and true, it immediately stores the offset, and in an X many interval, 5,000 milliseconds is the default, I think. So in 5 seconds time, it will then essentially commit that offset for me. There's a problem here though, right? If I was to essentially crash in the translator or the handler, I've marked that item as processed. And that's probably not what I want, right? I probably want to basically be able to say, okay, well, I crashed. It's okay. I can restart this and maybe that'll fix it, or I can redeploy it. Maybe that will fix it. But I don't want to lose that data. It's the whole point of having a stream or a queue. So how can I fix that? So the simplest solution, auto commit manually store offsets. Yep, is to basically manually store my offset, but still auto commit. If I manually store the offset, I get to choose when that happens. So here, I'm just going to say, hey, if we get all the way to the end and we're told that was a success, we successfully process that message, store the offset. If we fail, we're not going to do that. And so the offset's not going to be stored. So essentially, we're going to know that, hey, we didn't actually complete that. Right. Now, typically, you'd probably want to consider things like failure and that kind of thing, et cetera, and how you handle basically, well, hang on a minute, if I skipped one, et cetera. But this is a simplistic version. I think that it can get quite complicated. Brighter's got a lot of logic around how it handles this. But the auto commit is still true. So even though I'm choosing to say to Kafka, okay, this is the point I want you to store the offset, it will actually run a thread and commit it in the background. So it's saying every 5 seconds, just store it. The other option is to say, okay, I'm just going to commit that result myself. Don't store it. I'm going to actually just commit it to you. Right, so you say commit to false and auto set that door to false. So here I'm saying that rather than consumer store offset, I'm saying write that offset to Kafka. It has the advantage of there's not a whole lot of offsets sitting there in memory waiting for a thread. Okay. Has the disadvantage, obviously, that's very chatty. Typically, if you're manually committing offsets, what you tend to do is batch it up. So you wait until you get about 10, and you batch up the offset write. What Brighter does is something similar. It basically says we're going to batch up and write every 10, but because we don't want you to basically have 4 in the batch and then wait forever, we have a sweeper that essentially says, okay, but you can't live more than X many seconds before we'll write you. We have a kind of like a batch of this size, but no longer than this period. And that essentially means that you can effectively take direct control of what happens. Now, remember we talked about partitions and said how your work will be allocated partitions? So we also pointed out that in a given group, you might have less consumers than a number of partitions. So some of your consumers are going to be allocated multiple partitions. You've got to work a bit harder. If somebody says, okay, it's our typical ramp up time. So for Just Eat Takeaway, it's kind of like coming to food ordering time in the evening. Everyone wants pizza for their user group, right? You may probably increase the number of workers. But Kafka has to figure out, okay, you and you are going to lose that partition. It's going to be handed to this worker over here. So you will get effectively a message that tells you, or a callback that says the partition is being revoked. It's good practice to make sure that all of your offsets are committed at that point. This is actually going to be quite noisy if you do it naively like this. So we just made a bug fix in Brighter because it's a bit noisy, because that's just saying, hey, commit all the offsets that I've possibly got, regardless of whether they're actually on the server. So it's a bit smart. You can get a bit smarter. It tells you which offsets it knows about, and you can decide, is there anything I actually need to do here? Right. So that makes it less noisy, because otherwise it tells you, you tried to recommit this offset, but it's already committed, which is helpful, but just slightly annoying. So that is basically, you need to, when you lose the partition, commit stuff, right? If you just say auto commit, auto store, you wouldn't need to do this. It's going to get handled for you, right? So you're doing the relevant one, either storing the offsets that you've missed or making the commits that you've got basically manually waiting to be used, right? But if you do go down the route, which you probably want to avoid essentially committing offsets for work you didn't succeed at, you'll have to also take this step. All right. There's no difference between this and the last demo. So we're actually, I think, using this code. So I won't show you specifically how offsets are, because you can't really see anything. You may find you want to reset the offset to say, okay, actually, I want you to go back to here, right, for a given consumer group. It's a bit of a pain. There are some command line tools you can use to actually do offset resets. Typically, what most people do in real life scenarios is they just create a new consumer group and shove everyone in that new group and start again, right? There is code, Brighter doesn't actually directly support it at the minute, where you can do a seek, which says start this offset and read a certain number of records, and you can use that for reprocessing things. A lot of time people doing that just use something like KCAT, and they use command line tooling because that's what they're actually interested in doing, is inspecting something that failed. Yeah, I'm just showing that to 2. All right. Schema. Some of you that have heard about Kafka may have heard about schema. You may have heard about Avro. All right, let's talk about what this is. Kafka supports schema. In other words, registering with a schema registry the schema of the messages that you have, and enforcing, if you want to, for producers and consumers, that you must match that message. There are some rules about how you match. A lot of this is because Kafka often comes as part of an ecosystem of tools, including things like out of the box from Confluent, Connect, KSQL. There are things like Flink, etc., where it is helpful to understand the schema of the message that you're dealing with. Okay, so a Kafka record, both the key and the value can be Avro, JSON, or protobuf. So when we're using string, we're effectively just using JSON. So Avro is a binary format, typically associated with Kafka. Protobuf is obviously Google's binary on the wire format, and JSON schema you all know and love, right? And what you actually do is you basically say, I'm going to register the schema for the topic. Now, there's a thing called a subject, which determines the relationship of topics to schemas. I don't want to get into that. It allows you to have things like multiple schemas on topics and that kind of thing. For now, let's just assume, hey, I have a schema for my topic, right? Otherwise, we get lost in the weeds. Right. So this chart, don't worry, I got a simple version. This chart explains the compatibility rules for your schema, which you can enforce. It looks complicated, but it's a bit easier than that. So essentially, backwards compatibility means my consumer, which effectively is on a new schema, can be sent messages that had the last schema. Right? So I understand one schema back. They're typically useful effectively if your schema is exposing some kind of operation and you need to effectively support producers who can't migrate yet. More common forward is essentially producers using the new version can send messages to consumers with the last version. So I've got a new version of the message. Not all my consumers have been upgraded yet, but that's fine. The consumers, basically, the old consumers can still deal with this message, right? So things like new fields that are basically optional, etc. And full basically says both. Transitive in this list just means rather than one, all the versions, right? Which is quite a big ask. Generally, you care mostly about the last version because it lets you effectively roll out without moving everybody at the same moment in time. Right? Okay. So what happens? So your producer talks to a schema registry. From the schema registry, it gets the schema of the message that it's going to send, or it registers the schema. You can do both things. And essentially what happens is you tend to store those in local cache. You have a local cache because if this thing crashes, you don't want that to be end of your ability to send messages. You send that across the wire, and then typically, I don't tend to typically enforce on the consumer because we really care about Postel's law, which says be strict in what you send, be liberal in what you basically receive, but you can also enforce it on the consumer and does the same thing, right? And you can basically say, hey, if you try and produce something that doesn't match the schema, that's an error. And if you can, or doesn't match our compatibility rules, and similarly for consumer. Okay. As soon as you decide to use the schema, your Kafka life becomes a tiny bit harder. And that is because Kafka, when it was originally written, had no headers. It just had a body. So where am I going to put the ID of the schema that I need to look up in the schema registry to interrogate, to figure out the schema of these messages? Okay. So what Kafka does is it has a magic 5 bytes. And the magic 5 bytes consist of a version number, which is effectively always 0. I don't know why. Maybe one day it'll be 1 and we'll all break. The schema ID, and then the rest of your message. This causes you all sorts of pain. So we discovered on Brighter that, for example, saving this message, even as unless we saved it effectively as a byte 64 as a binary data, effectively, if you save it as UTF-8, it'll trunk it. The tools do their magic, and they say those first 5 bytes look like nonsense. I'll just chop them off for you. So it's a bit of pain. The other thing is essentially in .NET land, say you want to send a JSON message, you're basically not going to want to use system text JSON. You're going to want to use what's called the SERDES tools, which is serializer, deserializer tools from Confluent. There's one called JSON Serializer. JSON Serializer depends on Newtonsoft JSON. So effectively, you bring that back in after you spent all that time getting it out of all of your repositories and NJSON schema. Though it's an old version of NJSON schema, so if you want the current version of NJSON schema, you're out of luck. It's a bit of a mess. I think one of the things we're going to try and do on Brighter is support the schema registry for you so that you can use system text JSON, and we will deal with the magic 5 bytes on your behalf. don't have to thank me, but as David said, cache would be good. All right. So what happens? Basically, you create a schema registry client. So in .NET, that's the cache schema registry client. In other words, what that means is I'm going to save local versions of the schema in memory to avoid you making calls all the time. You can configure basically how your JSON serialization is going to work. And then essentially you use the JSON serializer to serialize, passing in the schema registry. Right. And lovingly, all of the basically schema registry methods are essentially async over async if your value serializer, because your value serializer method is essentially sync. And we all know we shouldn't really be doing async over async, but yeah. So it is, yeah. So that's another pain point you get to. Then your colleagues at work, I'll name no names, put slightly passive-aggressive notes in Slack saying, but Ian, why is it async over? Why are you doing sync over async? Welcome to the hell that is Kafka. Again, we may try and fix this for you so you don't have to do this misery. Okay. Right, to settle those, I will show you using the schema registry. That's the last demo, so then we'll be quick through the rest. Pair programming. There were spoilers here, but all right. So what you can see is the schema. So basically what's happened is it's saying, okay, the schema for this basically is transmodification settings, object, and effectively there's just some JSON schema. You can also see those by going into the Kafka UI if you told it where to find the schema registry, and it will show you basically what your schemas are for your given topics. Okay. All right, we are almost there. Oh, we are there, right. I think, yeah, so we won't talk about Brighter. We haven't got time, but Brighter, we do support Kafka, right? It's one of the transports we support. We are, I think, probably one of the best at supporting Kafka because we have this reactor model, which means we have a single-threaded message pump. We will guarantee ordering for you, which some of the others won't do because they basically use the thread pool for handlers, and they essentially can't guarantee they'll preserve the ordering. But yeah, I don't think there's much you can flick through quickly. I don't think there's anything worth showing you there. Yeah, anything there? Okay, yeah. Right. So sample code on GitHub. There is some sample code for that's where to get Brighter as well. This presentation, things that we didn't cover, things like Kafka Connect and KSQL. So because of its data engineering origins, Kafka is often used in data engineering context and comes with suites of tools that work around that area. Nowadays, to be honest with you, Kafka Connect and KSQL are losing their luster a bit. Even Confluent's kind of moving away from them. Problem with Kafka Connect is just the range of connectors are poor. I would recommend using something called Benthos if what you want to do is just move data between a database and a stream or a queue or vice versa. Benthos is much better for simple scenarios. For complex scenarios, they're not heavyweight enough, so people tend to use Flink instead. So rather than those first two, I would say lightweight scenario, just saying, I want to get stuff from a database into Kafka or vice versa. Benthos, complex data pipelines, Flink. Streams applications essentially let you do this kind of like reactive programming model on Kafka streams. It's essentially pretty much only directly supported in Java. There is a .NET port of the Java code. I've not tried it. I don't know how good it is. I asked Confluent, and they have no plans to support anybody other than Java with Kafka streams. Yeah. All right. So that is that. Thank you very much.
Anyone have any questions? Oh, there you are.
Sorry, I'm not sure if you touched on this earlier. I might have zoned out a little bit, but you spoke about the different acts and the different ways that you have like consistency across different clusters and such. How does Kafka handle that when you have like different clusters in different like data centers or different geolocations? Is there any like sort of trade-off in having that kind of system in place, and what can we do about that to make sure that we still have like some kind of like strict consistency where that kind of thing is needed?
So if you want strict consistency, the only way to get it really is to basically acts equals all across basically the nodes in the cluster. Generally, you don't want to run the nodes in the cluster sufficiently distributed that you're going to get with a problem with the latency between those nodes, or the partition, or too many partitions between those nodes, because Kafka will simply declare one of your nodes to be an out of sync replica, and then you'll tend to basically lose it. If you effectively find yourself in a situation where you have Kafka in one place and Kafka in another place, right, and you need to essentially move data between the two to replicate across regions, there's a technology called cluster linking, I think, which essentially lets you copy data from one Kafka cluster to another. You just turn it on. Typically, people in high-scale production environments don't tend to run their own Kafka anymore. They basically go to Confluent or Adyen or someone like that and say, can you run it for us? And typically, they'll run it in AWS or Azure or wherever basically you're set up. And usually, they will support something like cluster linking. There was an older technology than cluster linking whose name I cannot remember right now. So yeah, and that was a lot more error prone, let's say. So people use cluster linking usually now to make sure we're copying between different locations, and you can go and query that other Kafka instance in a different geographic location instead. Right. Nothing else? But we started with the hard questions. Come on, someone's got an easy one. All right, you're tired and you want to go to the pub, don't you, or home? I get it. All right.